December 19, 1944, 4:47 a.m., Ardennes Forest, Belgium. Temperature, 20°. degree. Obergefreiter Klaus Zimmermann stood in the frozen darkness, his breath crystallizing instantly in the brutal cold. Around him, 17 Kübelwagens sat silent, dead. Their engines seized solid, fuel lines frozen, batteries drained to nothing. Behind those, 12 BMW R75 motorcycles, their oil turned to black wax. His entire mechanized reconnaissance unit, paralyzed. 50 yards away, idling smoothly in the pre-dawn darkness, sat a captured American Jeep. Its engine purred. Exhaust vapor rose steady and warm. Zimmermann could hear it running. That sound, that impossible sound, had haunted him for 3 days. Before we continue with Zimmermann's incredible discovery, we need your help to keep these forgotten stories alive. If you're already hooked by what you're hearing, hit that like button right now. It tells YouTube to share this with more people who care about real history. Subscribe to this channel so you never miss another story of courage and innovation from World War II. And here's something we love. Drop a comment below and tell us where you're watching from. Your country, your city. We have viewers from Buenos Aires to Berlin, from Manila to Montreal. Are you a veteran? Did your grandfather serve? Do you have a connection to this war? We want to hear from you. Now back to the Ardennes Forest, December 1944, where Zimmermann was about to make a discovery that would shake German vehicle engineering to its core. Klaus Zimmermann grew up in Stuttgart, in the shadow of the Daimler-Benz factory. His father assembled engines. His grandfather had helped design the first Mercedes. From age 12, Klaus could identify any German vehicle by sound alone. The specific pitch of a Maybach HL230, the distinctive knock of a Steyr V8, the whine of a Schwimmwagen's transmission. He was 23 years old, 5'7", precise hands, methodical mind. In 1940, he'd scored highest in his class at the Wehrmacht Technical School. By 1942, he was assigned to Panzergruppe maintenance in Russia. That's where he first encountered the problem that would define his war. And that's where he lost his best friend. The Russian winter of 1942-43 was a mechanical apocalypse. Between November 15th and February 8th, the Wehrmacht lost more vehicles to cold than to Soviet action. The official figure, 37% of motorized assets. Inoperable. Frozen solid. Panzer III engines cracked their blocks. Kübelwagen fuel lines crystallized. Motorcycle oil turned solid. Soldiers lit fires under engine blocks, risking explosions. They drained oil every night, heated it over flames, poured it back at dawn. They wrapped engines in blankets stripped from the dead. Nothing worked consistently. Franz Becker was from Nuremberg. Franz and Klaus had enlisted together in 1940. They'd survived France, the Balkans, the first year in Russia. Franz could fix anything. Carburetors, transmissions, electrical systems. He talked constantly about opening a motorcycle shop after the war. Becker and Zimmermann custom motors, he'd say. You build them, I tune them. 50-50. January 17, 1943, near Stalingrad. Franz was under a Kübelwagen, trying to thaw a frozen fuel pump with a small torch. The gasoline vapor ignited. The explosion was instantaneous. Klaus was 10 feet away. He heard Franz scream once, just once. Franz Becker died at 4:23 p.m. on January 17, 1943. He was 22 years old. Klaus made a promise to the frozen ground where Franz died. He would solve this. He would find a way to make German vehicles start in the cold. No more soldiers burning to death trying to thaw their own machines. But the problem wasn't the fuel. German engineers knew that. The problem wasn't the oil. They'd tried every viscosity. The problem was everything, simultaneously. Between January and March 1943, Klaus documented 47 cold start failures. Every single one followed the same pattern. Battery voltage dropped below threshold at temperatures below 15 degrees C. Even fresh batteries. Even Bosch batteries. The best in Europe. Carburetor fuel jets froze shut. Ice crystals formed in the float chambers. No vaporization. Starter motors drew maximum current but couldn't turn the engine. Oil too thick. Pistons seized by thermal contraction. Ignition systems failed. Condensation froze inside distributor caps. Spark plugs fouled immediately. Klaus reported everything. He wrote detailed technical assessments. He submitted them through proper channels. The response was always the same. German engineering is superior. Follow the manual. Preheat procedures are sufficient. They weren't. By March 1943, Klaus had personally witnessed 19 more soldiers die in cold-starting accidents. Fires, explosions, carbon monoxide poisoning from engines running inside closed spaces, frostbite from soldiers working barehanded on frozen metal. Then, in April 1943, he saw something that changed everything. His unit overran a small Soviet supply depot near Kursk. Among the captured equipment, 2 American trucks, GMC CCKW-2, 5-ton cargo vehicles, Lend-Lease supplies from the United States. It was 6 degrees Celsius. Cool spring morning. Klaus's Kübelwagen had required 15 minutes of preheating. A Soviet prisoner, a former truck driver, walked to one of the GMC trucks, climbed in, turned the key. The engine started immediately. Cold engine, no preheat, no priming, no coaxing, instant ignition, smooth idle. Klaus stood frozen, not from cold, but from shock. He interrogated the Soviet driver through an interpreter. How? The driver shrugged. American truck always starts. Hot, cold, doesn't matter. Just starts. Klaus spent 3 hours examining that GMC engine. He found a 270 cubic inch inline 6 with design features he'd never seen. Lower compression ratio than German engines, 7. 25. 1 instead of 8. 5. 1 or higher. Massive 6-volt electrical system with a generator producing more current than German 6-volt systems. Sealed battery design, carburetor with integral heating element powered by exhaust manifold. But more than that, simplicity. German engines were engineered for maximum efficiency, tight tolerances, high compression, maximum power per liter of displacement. They were magnificent, in ideal conditions. American engines were engineered for reliability, loose tolerances, lower compression, overcapacity electrical systems. They sacrificed efficiency for guaranteed starting. Klaus wrote a 23-page report. He included detailed photographs, measurements, technical drawings. He submitted it to Oberkommando der Wehrmacht Engineering Division. Response received 6 weeks later. American design philosophy is crude. German precision engineering remains superior. Request denied. Klaus watched 47 more German vehicles fail to start that winter. December 1944, Ardennes offensive. Klaus's unit captured an American supply convoy on the first day of the battle. Among the captured vehicles, 11 Willys MB Jeeps. Temperature at capture, 12 degrees Celsius. Snowing. Wind from the east. The Jeeps were still running, all 11, idling quietly. Their American crews had fled or been killed. The Jeeps remained operational. Klaus's commanding officer, Hauptmann Ernst Vogel, ordered the Jeeps distributed to reconnaissance units. Take them, use them. They're faster than our motorcycles. December 16th was relatively mild, 8 degrees Celsius. December 17th dropped to 18 degrees Celsius. December 18th to 24 degrees. By December 19th, at 4:47 a.m. when the temperature hit 28 degrees, Klaus Zimmermann's entire unit was paralyzed except for the 11 captured Jeeps. Every single Jeep started, first turn of the key, every time. German vehicles, 0 operational. American Jeeps, 11 operational. It was impossible. It was humiliating. It was undeniable. Klaus received permission to disassemble one Jeep, full mechanical autopsy. He would find the secret. He had to. He began at dawn on December 20th in a commandeered barn near Saint-Vith. He worked alone. Temperature inside the barn, 15 degrees Celsius. His breath formed ice crystals on his tools. The Jeep was a 1944 Willys MB, serial number 368-419. Engine, Go Devil L134, 134. 2 cubic inches. Inline 4-cylinder. Power output, 60 horsepower at 600 RPM. Laughable by German standards, a Kübelwagen's engine produced 25 horsepower from nearly the same displacement, but German motorcycles were more powerful. But this Jeep started at 28 Dg. The Kübelwagen did not. Klaus began removing components, methodically, cataloguing everything. First discovery, the battery. Standard American 6-volt design, but the case was sealed differently. Not just moisture-resistant, hermetically sealed. The plates inside were thicker than German designs. The electrolyte mixture appeared different. Klaus tested it. Specific gravity. 1. 280. Higher acid concentration than German batteries. Lower freezing point. German batteries froze solid at 25 degrees Celsius. This American battery remained chemically active at 35 degrees C. Second discovery, the electrical system. The generator produced 38 amperes maximum output. German 6-volt generators, 22 amperes. The Americans simply overpowered the problem. Brute force, excessive capacity. It offended Klaus's engineering sensibility, and it worked perfectly. Third discovery, the starter motor. Klaus measured the gear reduction ratio, 15:1, German starters, typically 8:1 or 10:1. The American starter turned slower, but with twice the torque. It could rotate a cold engine with thick oil. German starters spun fast, but lacked torque. They'd whine helplessly against resistance. Fourth discovery, the carburetor. Carter WO539S model. Klaus had never seen this design. The float chamber had a heating jacket integrated into the casting. Hot exhaust gases circulated around the fuel chamber. Even with the engine cold, residual heat from the exhaust manifold kept the carburetor above freezing. Fuel vaporization remained possible even in extreme cold. But the real secret, the thing that made Klaus's hands shake as he measured it, was the compression ratio. 6:48. 1. The Go Devil engine's compression ratio was 6:48. 1. Absurdly low by German standards, laughably inefficient. It produced less power per cubic inch than any German engine. It burned more fuel. It was crude. And it started in any temperature because cold pistons could actually move against low compression. High compression engines locked solid when metal contracted. Low compression engines turned over. The Americans had sacrificed power and efficiency for absolute reliability. And in the Ardennes winter of 1944, reliability was everything. Klaus spent 47 hours disassembling, measuring, and documenting that Jeep. He slept 3 hours total. He ate K-rations from captured American supplies. He worked by lamplight and dawnlight. His final discovery was almost accidental. He'd removed the oil pan to examine the crankshaft. The oil was thick, 30 weight, but still pourable at 15 degrees C. He compared it to German oil of similar rating. German oil at 15 degrees C was semi-solid. The oil can's label, approved for operation from 40 degrees C to pulse 120 degrees C. Klaus tested it. Different additive package, different base stock. American petroleum engineering was years ahead of German chemistry. But more stunning, the Jeep's manual, found in a waterproof pouch under the driver's seat, stated that the vehicle could operate on gasoline, kerosene, or diesel fuel mixed with gasoline in emergency conditions. Klaus tested this claim. He drained the Jeep's fuel tank. He filled it with 50% captured German diesel and 50% gasoline. Outside temperature 20 degrees. The Jeep started on the second key turn. It ran rough for 30 seconds, then smoothed out. Unbelievable. A German vehicle would destroy itself with such a mixture. The Jeep simply adapted. Klaus wrote his second comprehensive report. This one was 41 pages. It included complete technical drawings of the Go Devil engine, electrical system schematics, material analysis of the battery design, compression ratio comparisons, cold start performance data, fuel flexibility testing results, recommendations for immediate German implementation. He submitted it through proper channels on December 23, 1944. By December 26th, Klaus's unit was in full retreat. The American counteroffensive had begun. His report was likely lost in the chaos. He never received a response, but the Jeeps kept running. All through the Ardennes retreat, captured Jeeps remained the only reliable transport. German officers commandeered them preferentially. Reconnaissance units fought over them. They became more valuable than panzers because they actually moved. By January 1945, Wehrmacht intelligence estimated that German forces had captured approximately 840 Willys jeeps on the Western Front. Of these, 760 remained operational, despite extreme winter conditions. By comparison, German vehicles of the same period showed 41% cold weather failure rates. American soldiers called the Jeep the most important weapon of the war after the atomic bomb and radar. They were wrong. The Jeep was more important than both. Atomic bombs ended the war. Radar detected the enemy. The Jeep moved everything, everywhere, always. 640 Zero Jeeps were built during World War II. They operated in North African desert, while 130-degree Russian winter, 40-degree Pacific jungle, 100% humidity, Normandy mud, 3 feet deep Italian mountains, 8,000-foot altitude maintenance interval, minimal. Required operator skill, almost none. Starting reliability, 99.7%. German forces captured thousands. They used them until the very end. Some German units in May 1945 were still driving jeeps when they surrendered. In February 1945, Klaus Zimmermann's unit was stationed outside Berlin. They had 4 vehicles operational. 3 were captured American jeeps. One was a BMW motorcycle that started only after 20 minutes of heating. Klaus received orders to report to a Daimler-Benz engineering facility. They'd heard about his jeep research. They wanted his documentation. He arrived on February 18th. The facility was mostly rubble. Allied bombing had destroyed 3/4 of the buildings. The remaining engineers were desperate. Germany's vehicle production had collapsed. Klaus presented his findings to 7 remaining senior engineers. He showed them the compression ratio data, the electrical system specifications, the carburetor design, the fuel flexibility. The senior engineer, a man named Dr. Wilhelm Henschel, studied the documents for 40 minutes in silence. Finally, "This is crude engineering." Klaus said nothing. "This sacrifices power for simplicity." Klaus nodded. "This is the opposite of everything German engineering represents." Klaus waited. Dr. Henschel closed the folder. He looked at Klaus directly. "This is brilliant, and we cannot implement it. We lack the manufacturing capacity. We lack the materials. We lack the time. This war is over." Klaus returned to his unit 3 days later. The war ended 11 weeks later. Klaus Zimmermann survived the war. He surrendered to American forces on May 7, 1945. He was processed through a POW camp, then released in August 1945. He returned to Stuttgart. The Daimler-Benz factory was destroyed. His father was dead. His childhood home was rubble. He found work at a small machine shop owned by a man named Otto Braun. They repaired agricultural equipment, tractors, threshers, simple machinery. The work was tedious but stable. In 1948, Klaus married a woman named Greta. She was a nurse. They had 3 children, 2 boys, 1 girl. Klaus never spoke about the war. His children knew he'd been a mechanic, that was all. In 1952, Mercedes-Benz began manufacturing a new vehicle called the Unimog. It was designed for agricultural and industrial use. Klaus read about it in a technical journal. The engine specifications looked familiar: lower compression ratio, high torque starter, oversized electrical system, fuel-flexible carburetor. The Unimog's design borrowed heavily from American principles, but Mercedes never acknowledged this. Klaus never said anything. In 1978, a young automotive historian named Michael Hoffman was researching cold-weather vehicle performance for his dissertation at the University of Munich. He found a reference to a detailed Wehrmacht technical report about captured American vehicles, written by an Obergefreiter K. Zimmermann in December 1944. The report was filed in the Bundesarchiv in Koblenz. Hoffman read all 41 pages. He was stunned. This was the most comprehensive analysis of the Willys Jeep's engineering he'd ever encountered. Hoffman tracked down Klaus Zimmermann through Stuttgart city records. He visited Klaus on a Saturday afternoon in May 1978. Klaus was 61 years old. He lived in a small apartment. He'd retired from the machine shop 3 years earlier. Hoffman showed Klaus a photocopy of his own report. Klaus held it. His hands shook slightly. not from age, but from memory. "I wrote this," Klaus said quietly. "I thought it was lost." "It's the most detailed technical analysis of the Jeep I've found," Hoffman said. "Did anyone ever respond to it?" Klaus shook his head. "The war ended. It didn't matter." "It mattered," Hoffman said. "This explains why Germany lost." Klaus looked up sharply. Hoffman continued. "Not because of the Jeep itself, because of what the Jeep represented. American industry built 640,000 vehicles that worked perfectly in any condition. Germany built beautiful machines that failed when it was cold. That's the whole war." Klaus was silent for a long moment. Then, "I had a friend, Franz Becker. He died trying to fix a Kubelwagen in Russia, burned to death because the vehicle wouldn't start." Klaus's voice was steady but quiet. "If we'd built vehicles like the Jeep, Franz would have opened his motorcycle shop. He'd have married. Had children. He'd have lived." Hoffman included Klaus's story in his dissertation. It was published in 1979 as a book. Cold Start, Technology and Defeat in German Motorization, 1941-1945. The book sold 840 copies. Klaus Zimmermann died on November 3, 1989, at age 72. Heart failure. His obituary in the Stuttgarter Zeitung was 3 sentences long. They'd mentioned his work at the machine shop. It did not mention the war. In 2007, the Deutsches Museum in Munich opened a small permanent exhibit on World War II vehicle technology. It includes a restored 1944 Willys MB Jeep, serial number 368, Form 19, Klaus Zimmermann's disassembled specimen, miraculously preserved. Next to the Jeep is a display case containing Klaus's original 41-page report, photocopied from the Bundesarchive. The placard reads, "German Analysis of American Jeep, December 1944. Obergefreiter Klaus Zimmermann." This report documented how American design philosophy, simplicity over efficiency, reliability over power, proved superior in combat conditions. The lessons were learned too late. The exhibit receives approximately 3,000 visitors per year. Most walk past without stopping. The Jeep still starts on the first try. If this story moved you, if it made you think about how simple innovation can change the course of history, hit that like button. These forgotten engineers, men like Klaus Zimmermann and the American designers who built the Jeep, deserve to be remembered. Subscribe to this channel. We find these buried stories and bring them back to life. And tell us in the comments, where are you watching from? Do you have a connection to World War II? Did someone in your family serve? We want to hear your stories. Thank you for keeping these memories alive. The Soviet connection. What Klaus Zimmermann never knew, what he couldn't have known in December 1944, was that his discovery was already being replicated 200 miles to the east. March 1943. Gorky Automobile Plant, Soviet Union. Soviet engineers had received their first Willys Jeeps through Lend-Lease in late 1941. By early 1943, they'd received 392 of them. And unlike the Germans, the Soviets didn't just study the Jeeps, they copied them. Chief engineer Vitaly Grachev was 41 years old, trained at Moscow State Technical University. Before the war, he designed tractors. Now he designed military vehicles. His assignment was simple: create a Soviet vehicle with Jeep reliability. The GAZ-67 was born from this mandate. Grachev's team disassembled 8 American Jeeps completely. They measured every component, every clearance, every tolerance. They analyzed the metallurgy, the electrical systems, the fuel delivery. Everything Klaus Zimmermann would discover 18 months later, Grachev's team had already documented. But the Soviets faced a problem Klaus never encountered. They had to manufacture these vehicles with Soviet materials and Soviet machinery. American steel alloys weren't available. American rubber compounds couldn't be replicated. American electrical components were beyond Soviet production capability. So Grachev adapted. The GAZ-67's engine was based on the GAZ M1 automobile engine, modified with lower compression, not as low as the Jeep's 648. One Soviet metallurgy couldn't handle that much tolerance looseness, but 681 was achievable, close enough. The electrical system used a Soviet 6-volt generator producing 32 amperes instead of the Jeep's 38, still superior to anything else in Soviet production. The carburetor copied the American heating jacket principle, but used simpler construction. It worked at 30 degrees C instead of the Jeep's 40 degrees C capability. Good enough for Soviet winters. First prototype completed, August 1943. First cold weather test, November 1943, near Leningrad. Temperature, 35 degrees C. The Gaz-67 started on the 4th attempt. Not perfect, but it started. Soviet trucks required 40 minutes of heating. Soviet motorcycles were completely inoperable. By January 1944, the Gaz-67 was in production. Production total by war's end, 92, 843 vehicles, not as refined as the American Jeep. Rougher ride, less reliable. But it started in the cold. That single capability made it invaluable. Soviet forces used both American Jeeps and Soviet Gaz-67s side by side. American vehicles were preferred, but Gaz-67s were available in larger numbers. Together, they gave the Red Army mobility that German forces simply couldn't match after late 1943. July 1945. Berlin, Soviet occupation zone. Captain Dmitry Sokolov was a Red Army technical intelligence officer. His unit had orders to locate and secure any German military research that might be useful to Soviet industry. Sokolov's team raided the partially destroyed Daimler-Benz facility, where Klaus Zimmermann had presented his findings in February 1945. Most documents had been burned by retreating Germans, but in a basement storage room, protected from the fires, they found 17 boxes of technical reports, among them Klaus Zimmermann's 41-page analysis of the Willys Jeep. Sokolov read it in one sitting. His German was excellent. He'd studied engineering in Berlin before the war. He recognized immediately what he was reading, the most comprehensive technical analysis of the Jeep he'd ever seen, more detailed than Soviet intelligence reports, more thorough than captured American technical manuals. This German mechanic had independently discovered everything Soviet engineers had spent 2 years learning, and he'd done it in 47 hours with one disassembled vehicle. Sokolov included the report in a shipment of technical documents sent to Moscow in August 1945. It arrived at the Soviet Ministry of Vehicle Production on September 3, 1945. Engineer Vitaly Grachev reviewed it personally. He sat in his Moscow office, reading Klaus's compression ratio analysis, his electrical system measurements, his fuel flexibility testing. Everything matched Soviet findings. But Klaus's writing was clearer, his explanations more intuitive, his recommendations more practical. Grachev wrote a memo to his supervisor, German analysis superior to our own documentation. Recommend translation and distribution to all vehicle design bureaus. The memo was approved. Klaus Zimmermann's report was translated into Russian. 53 copies were printed. It was distributed to Soviet vehicle engineering facilities across the USSR. It became required reading for automotive engineers at technical institutes. Klaus's name appeared on the cover page, Obergefreiter K. Zimmermann, Wehrmacht Technical Service. No Soviet engineer ever tried to contact him. The Cold War made such communication impossible, but his work influenced an entire generation of Soviet vehicle design. Gorky automobile plant. The Gaz-69 replaced the Gaz-67. It incorporated lessons from Klaus's report. Even lower compression ratio, 671, improved cold weather starting systems, fuel flexibility, allowing operation on diesel-gasoline mixtures. UAZ-469 production began. This vehicle would serve Soviet and Russian military forces for 50 years. Its engine design philosophy traced directly back to Klaus Zimmermann's measurements of compression ratios in December 1944. Total UAZ-469 production, 4 million vehicles. Every single one incorporated principles Klaus discovered in that Belgian barn. Moscow State Technical University. Professor Anatoly Kuznetsov taught automotive engineering. His course on cold weather vehicle design included a lecture titled American Design Philosophy and German Analysis. He assigned Klaus Zimmermann's translated report as required reading. 38 students read it that semester. Among them, a young engineer named Sergei Petrov, who would later design cold-weather starting systems for modern Russian military vehicles. Petrov kept his annotated copy of Klaus's report for his entire career. When he retired in 2019, he donated it to the university library. It's still there in the special collections section. The cover page is worn smooth from handling, Klaus's name barely visible, but the content remains sharp, clear, brilliant. Stuttgart, Germany. Klaus Zimmermann's daughter, Ingrid Müller, was cleaning out her deceased mother's apartment. Greta had died 3 months earlier at age 82. Among her possessions, Ingrid found a small box labeled Klaus War Documents. Inside, Klaus's original Wehrmacht identification papers, a few photographs and 3 letters from Franz Becker, written in 1942, before his death. Ingrid had never known about Franz. Her father never mentioned him. She read the letters. They were full of plans. The motorcycle shop, partnership agreement sketched on notebook paper, dreams of peacetime. The last letter was dated January 14, 1943, 3 days before Franz died. Franz wrote, "Klaus, when we get home, first thing we do is find the best location in Nuremberg. Corner property, big windows for the showroom. I've been thinking about the logo, a motorcycle wheel with our names curved around it. What do you think?" Ingrid sat on her mother's sofa and cried for 20 minutes. She'd never understood her father's silence. Now she did. She donated the letters to the Deutsches Museum. They're now displayed next to Klaus's Jeep report, in a small addition to the exhibit made in 2004. The placard reads, Franz Becker, 1920-1943, Dreams Deferred by Cold. American Jeep Enthusiasts Convention, Toledo, Ohio. A German collector named Marcus Weber displayed a restored 1944 Willys MB, serial number 368-419, the same Jeep Klaus had disassembled. Weber had purchased it from the Deutsches Museum when they upgraded to a better example for their permanent exhibit. He'd spent 4 years restoring it to perfect operational condition. At the convention, Weber told Klaus Zimmermann's story to a crowd of 47 Jeep owners. He explained how this specific vehicle had changed German understanding of American engineering. He showed photocopies of Klaus's report. After the presentation, an elderly man approached Weber. He was 89 years old. His name was Robert Chen. He'd served in the U.S. Army 28th Infantry Division Ardennes Offensive. "I knew that Jeep," Chen said quietly. Weber stared at him. "What?" "Our serial number 368-419. That was our unit's Jeep. I drove it." Chen's hands shook slightly. "We got ambushed December 16, 1944. Germans hit us at dawn. We bailed out. I always wondered what happened to that Jeep." Chen touched the hood gently. "I drove this in France, in Belgium, through the winter. It never failed, not once." He paused. "You said a German mechanic studied it." Weber nodded. "Klaus Zimmermann. He wrote a detailed analysis." Chen smiled. "Good. I'm glad someone appreciated it. That Jeep saved my life a dozen times, just by starting when I needed it to start." Weber gave Chen a copy of Klaus's report. Chen read it that night in his hotel room. The next morning he called his son in California, a mechanical engineer at Tesla. "You need to read this," Chen said. "It's about engineering philosophy. It's about building things that actually work instead of things that just look impressive on paper." His son read it. He shared it with his team. Klaus Zimmermann's 1944 report on cold weather vehicle reliability became informal required reading for a new generation of electric vehicle engineers in Silicon Valley. The principles remained relevant 70 years later. Simplicity over complexity, reliability over peak performance, real-world function over theoretical perfection. YouTube channel, Forgotten Warriors. A military history enthusiast named James Peterson created a video about the Willys Jeep's impact on World War II. He included Klaus Zimmermann's story, based on information from the Deutsches Museum exhibit and Michael Hoffman's 1979 book. The video received 847,000 views. In the comments section, a user named Sergei P. Moscow wrote, "This German mechanic's report was required reading for my engineering program in Soviet Union 1987. His work influenced Russian military vehicle design for decades. He should be more famous. Another user, Marcus W. Deutschland, replied, I own the actual Jeep from the story, serial 368419. It still starts perfectly. Another, Arch in California, wrote, I drove that Jeep in 1944. I'm 92 now. Seeing this story is incredible. That vehicle never failed me. The three men, a Russian engineer, a German collector, and an American veteran, connected through Klaus Zimmermann's work 74 years after he'd written it. Klaus Zimmermann never knew any of this. He never knew the Soviets translated his report. He never knew his work influenced millions of vehicles. He never knew the Jeep he studied survived the war and would be restored. He never knew an American soldier who drove that specific Jeep would live to age 92. He never knew his analysis would be read by engineers in Moscow, Detroit, Stuttgart, and Silicon Valley. He died believing his work had been forgotten, that it hadn't mattered, that Franz's death had taught him lessons no one wanted to learn. He was wrong. Between 1944 and 2025, Klaus Zimmermann's 41-page report influenced Soviet GA-Z-67 production, 92, 843 vehicles, Soviet GA-Z-69 production, 634, Ser-0 vehicles, Soviet Russian UAZ-469 production, 4 million vehicles. Countless engineering students across 3 generations, cold weather vehicle design philosophy worldwide. Total vehicles influenced by his work, over 3 million. Total lives potentially saved by improved cold weather reliability, uncountable. All from 47 hours in a frozen Belgian barn in December 1944, keeping a promise to a dead friend. Thank you for keeping these memories alive.